Welcome. In this video, I'm going to show you an application of the chain rule. A city's weekly flu cases C in hundreds depends on the vaccination rate V, percent of residents vaccinated. The vaccination rate now depends on public health spending S in billions of dollars. At a certain time, that is when spending S is 12 million, DC over DV, that's the change in weekly flu cases in hundreds over the change in the percent of residents vaccinated is negative 3.2. DVDS is 1.5, so that's the rate of change of the vaccination rate with respect to public health spending. We're going to compute and interpret DC over DS. So to put this in words, what is it that we want? We want the change in weekly flu cases. We want to examine how those weekly flu cases change with respect to changes in public health spending. Okay, so let's get a handle on our functions. And let's start first with C. So C is the weekly flu cases in hundreds. And what does this depend on? It depends on the vaccination rate. So C is a function of V. Okay, so we would write that as CV. Now, what about V? The vaccination rate, V, depends on public health spending, S. So V is a function of S. So we would write V of S. And remember, our goal here is dC over ds, which is really just C prime of S. So we're going to have to use the chain rule here because remember, C is a function of V and V is a function of S. So let's go ahead and use the chain rule. Let's apply the chain rule. So C prime, we take the derivative of the outer function, leave the inner function unchanged, and then multiply by the derivative of the inner function, which is V prime of S. And now using this notation here, let's go ahead and match it up now. Well, dC over dV, that's here, that's C prime. That's the derivative of C with respect to V. So let's go ahead and write that out, dC over dV. Okay, and then to that, we're multiplying the derivative of the vaccination rate with respect to public health spending. That's this one, that's here. Okay, so let's go ahead and multiply that one, dV over ds. And we're given what these values are. We're told that these values are negative 3.2 times 1.5. And here I'll color code these again just to keep this consistent, is where these values are coming from. All right, now what is that? This becomes negative 4.8. Now remember, the weekly flu cases are in hundreds, so that's right here. So the weekly flu cases are in hundreds. And what we just worked out was the derivative of C with respect to S. So the change in weekly flu cases with respect to public spending. So since these flu cases are in hundreds, let's work out exactly how many that is. So we'd multiply negative 4.8 times 100 to get negative 480 right there. And then one last thing, just to make it really, really clear here, which I don't think I made it clear enough, what we worked out, this right here, is our goal. It's dC over ds because we evaluated the derivative of C with respect to S, which was the goal all along. So let's make this really clear. This was our goal here, and we got it. But since V is a function of S, we had to multiply by the derivative of V. And there it is how we use the chain rule. All right, so what does this all mean? More importantly, at $12 million in public health spending, increasing spending by 1 million is associated with 480 fewer flu cases per week. And then if you're wondering about this negative here, by writing 480 fewer, that's the implication. This tells me that flu cases are going down, this negative sign. So I didn't write negative 480 fewer flu cases. I just wrote 480 fewer because I know this rate of change is negative. Flu cases are going down as public health spending increases. All right, please keep calm and math on.